Hi, I'm Tom and I talk about code. Welcome to another Rust programming livestream where I'm building my compiler for my own programming language to run on my own 16-bit virtual machine. Today, we are going to be diving into recursion because currently, when I have a function that tries to call itself, that for some reason breaks. Last time, I wrote a bunch of tests to try and highlight where this problem was. It turns out I had a problem in my if statements with how I was jumping in them. So I fixed a couple of issues, but recursion is still broken. It works, it runs, it does something, but it seems to break down when it tries to call itself, and we absolutely do not get the correct value returned out from a function when it's recursive. My goal is to do Fibonacci numbers, because Fibonacci numbers are cool. So there are two avenues by which I want to try and approach this. One is to maybe try and find a better test case, or a different test case that highlights what's going on. The other would be to refactor some of the stuff to be a little bit cleaner and maybe easier to test, but for now I'm just going to try running these tests and see if there's an obvious thing that stands out to me, an obvious avenue to go down. So I'm just going to sneakily do something in the background. Okay, beautiful. And then we will begin. So, when I run these tests, we're going to see that there's a failure. If I go into my compiler, I test, we see that the recursive call failed. Now, as part of running this test, it actually logs out every instruction that it runs. Right, so we can see what's going on here. It starts off up here, it sets up the stack, it jumps into our main function. Our main function does a couple of things, puts some stuff onto the stack, and then it's gonna jump to instruction 66. Jump to address 66, sorry. Address 66. At address 66, it does our test, and we would expect to see it jump again to address 66, which it does a second time. And a third time, maybe? Maybe not. But we see this recursion happening, okay? So let's have a look at the test that we're running. Lang mod recursive calls. Okay, so we're expecting to see this run a few more times than it does. We're running out of steam early. We would expect this to call itself, quite a few times. So let's maybe try lowering this number. What if this is just 1? Do we, sorry, if I make test, do we get a correct answer? No, we still end up with nothing in the A register afterwards, which is a bit of a problem. We return everything through the A register, so we expect the A register to hold something, anything, anything at all. Okay. See, I wrote these tests for deep function calls, and these work fine. Things get returned out. So there's something about calling ourself that must maybe corrupt the stack. That would be my guess. So let's maybe see if we can compile this program. Let's echo. Let's just make a file called A. Whoops. That's the wrong thing. Let's make a file called A. Let's go into mod. That was what I just announced. Test mod. What did I call it? Lang tests mod. Let's grab this test case and let's run it through our compiler such that we can actually get the binary and play with it. Okay, so cargo run. I was in the wrong directory. That's okay. That happens. Now we're gonna run our disassembler and we're gonna copy the output. And I also need to make sure that I'm running my web server. Excellent. Okay. So let's jump over, let's run this, and let's try stepping through it. And this is what I've been doing. Localhost. This is what I've been doing for the last 2 or 3 streams, but we're going to continue doing it, right? We're going to continue doing it until it works. Oops. And that didn't copy for some reason. That didn't copy because I forgot to tell the disassembler to do anything. Okay, so now if we compile this, we can step through it and see what is actually happening. And this is the part where it gets interesting, right? This is where we jump in, and we jump into a second function, which is at address 66. Okay, so address 66, add 0 to our stack pointer. See, this is where we do the test to see if the argument is less than 1, at which point we do some stuff. You see, I move the PC up, push C, the program counter, push, PC. Yeah, so this is where we then start to do this iterative recursive call. The program counter, so from address 126, we seem to be calling ourselves again, which is good. Ignore this tail, this is a little bit of a broken visualization. You can kind of see it leaks, the thing that it is a bit complicated, I guess. You can kind of see, right? Tail, I can't highlight this for some reason, I don't know why. I must have made this not selectable. Anakin Luke says light mode. I know it's a bit ridiculous. I need to add a better color scheme for this. But as we step through this, we're gonna see that this stack is gonna get built up, and I'm signed or not. We start returning. But for some reason, okay. So this is the problem. We don't actually end up C0. So at what point should we get something into the A register? We should get something into the A register when we return this file, return A. I wonder if I say let int I equal a x minus 1 y plus 1 and then return I wonder if this will work. Except it shouldn't, because we should be hitting this branch anyway. Let's just try this out and see if we get something different in the A register. Compile and run. And we get 1 in the A register, which isn't right, but it's something, because before this was just 0. So do we get MC7? We do. 7 gets pushed onto the stack. But for some reason we're maybe not loading that correctly. So we would expect after we do the test when we jump into A, okay? After we do the test when we jump into A, we should push the second argument, we should load the second argument into the A register and then jump back to main, right? So why doesn't that happen? Let's see if we can do that. Let's see if we can see this happening. Okay, so we jump into our first function call. Main is at address 16 apparently. We push 1 and 7 onto the stack, which is good. We can kind of see, for some reason, I don't know, this seems a bit backwards, but whatever. 7, 1. Are our arguments backwards? See, this is the other thing. We're probably... Step. So if I start stepping through here, we push C, we push 7, we load 7 there, test if C. Okay, no, so that's correct. That works correctly. We're testing if 7... No, we're testing if 7 is less than 1. Yeah, the args are backwards. That explains so much. Okay. And because the way I've defined my calling convention, right? I've said that you start with arg n. Have I? What have I said? Have I said you start at arg n, right? You push the last arg first, then arg n minus 1, then ... then eventually arg 0, the base pointer the program counter, and then local 0, local 1, etc. Right? It looks like this. So I suspect that I'm treating this as argn and this is arg0. I just need to push them in the opposite order. Anakim Luke says there's an extension called Dark Reader that makes every site dark. That's pretty cool. Yeah. Well, in this case, I control this. Whoa. I don't know what happened there. Where did my chat go? In this case, I control the site, so I can just make better CSS. Currently there's no CSS, right? There's nothing. Not a thing. Not a thing. Okay, so let's go into the code that calls a function. Call here, and we can see that we iterate over args. Now, does Rust have... Actually, hold on. Let me get the docs of the toolchain I have installed. Rust up doc. Nice. This is really good. I love being able to do this, and then we know it's exactly correct for the exact platform we're on. Okay. So I'm looking for reverse. Is there a reverse iterator? Rev, here we go. Reverse is an iterator's direction. Perfect. We can do that. Args.iter.rev. And I think I need to borrow this. Okay, no, I need to not borrow it. There we go. And now we have this. Yeah, so now it is actually borrowed. Can we do that? Okay, expression does not implement clone. AST, what is in an expression? Enum expression. I don't think we can clone this, right? Because of the box. Oh no, that's fine. Clone. Okay, we can't clone. Well, we can clone an identifier. And we can clone a binop. Definitely. We can copy and clone a binop. Not that one. I want make B. Okay, expression. Now we can clone it. Cool. That was actually fine. Bobius, how's it going today? Today is good. Today is cold. My feet were getting sore from standing on my floor, but I've got lots of layers on as always at this time of year. You know, anyone who's from countries where you have sensible insulation, man, that would be really nice. And like heating in more than one room, it sounds real nice. Everything's just cold here. It's been like, you know, 2-3 degrees in the morning, and probably not too much warmer than that inside, honestly. Like maybe, you know, 10 degrees or less inside. It's been fucking awful. Don't recommend. I'm spending a lot of money on heating at the moment. A lot of money, because there's a massive window next to where my heater is that's, you know, a 2.5, almost 3 meter wide single glazed window. And it turns out that having that immediately next to your heater, I can literally feel a cool draft coming through that, like just through the glass when it's, you know, 5 degrees outside, even when my heater is running and directly pointed on me, because it kind of hits the window as well, and then some weird thermodynamics happens. I'm convinced one day I'm gonna have like an inside, like a hurricane or a tornado in something. There's gonna be like a high pressure system form in my kitchen and tear through my living room. Anyway, neither here nor there. That's not the most important thing going on right now. Okay, now we get a different answer when we run this test. We get a subtract with overflow. Subtract with overflow. Okay. Now this is interesting. This is very interesting, because when we subtract, this is actually illegal. We're not allowed to subtract anything from 0 in Rust. Also, hold on. I need to rerun Vim, because I'm in a very... I ran Vim in the wrong directory. It's a bit silly. Yeah, my god. See, like Australia is kind of stuck in this mid ground where it's like it gets cold. It gets really cold. Like the place I grew up is not this cold. Melbourne gets cold, but also people aren't gonna like die because we don't have insulation. It just means you have to spend a shitload of money on heating. And you know, wear like 6-7 layers around the house. Yeah. How cold is it here? Right now it's probably like it's a bit warmer today. It's probably 10, maybe 12. Let me check. Let me go to the. This is really cool. So the Bureau of Meteorology in Australia. Sorry to get distracted. I know people are really invested in this coding journey, but the Bureau of Meteorology in Australia does not support HTTPS. So you do this, then you always get redirected. So no matter what link you follow through from a search engine, you always come back to the homepage. It's 13 in Melbourne right now. That's not too bad. It might be a bit colder where I am exactly, but you know, this is as warm as it's going to get today. It was much colder than this morning. Getting to min of 8. I think today, this morning was colder, and I've had a couple of mornings that have been like 1 or 2, which, yeah. Oh, XMDIO with a raid. Thank you so much. Welcome. Coming in right as I get distracted and start talking about the weather. Probably the least interesting topic anyone has ever considered. Thank you very much for the follow. What were you working on? What were you doing? Are you a programming streamer as well? Okay, so I probably at some point need to have better behavior. I think basically because this is a 16-bit virtual machine, it's okay if my instructions just, like my subtractions just underflow. I think that's okay. And there's a way to do this. If I look at, well, it'll be U16, right? So U16. Wrapping add. Is there no wrapping subtract? Did I to do make this work? Look, that's kind of close. Rockstar modder hash 8706. Thank you very much for the follow. Welcome. Wrapping. I would love a wrapping subtract. Is that not a thing? Wrapping sub. I16 used wrapping sub. Why couldn't I find that? Can I just not read? Wrapping mode distraction, wrapping around by the boundary of the type. Okay, so let's change it to this actually. So we want a dot wrapping sub b. Beautiful. So we're not going to crash like that anymore. We just get the wrong answer, but we actually return something in the A register, which is really good news. That's very, very good news. Okay, this is good. So, everyone coming in, this is my own programming language that I'm writing for my own virtual machine, which is pretty tedious apparently, actually. I'm learning the hard way. So let's compile this new program and let's step through and see what is going on. Because hopefully, we're actually getting the right arguments into the functions in the right spot. Rockstar Modder, good morning. It has just gone 12:15 here, so I've just missed good morning. Super Cricket's right with good afternoon. Super Cricket, one of the few people further in the future than I am. How's everything going in the islands? out in the ocean, Super Cricket. How is life? Okay, so C, we load 1. We push, we pop, we do some horrible stack manipulation, and we test the number 1. Because this is what we're doing. We've got this test program here, okay? We want to test if this first argument is less than or equal to 1. This argument is 1. So as we step through here, we expect that we're now going to load the number 7 into the A register, okay? So we're in our truthy part of this block. We load 1, push to the stack, load stack offset. Okay, here it is. That's the number 7. And now we recurse. For some reason, we call this function again, even though we shouldn't. Super cricket, rainy and cold, bought a bed, curled up in it half the day. That has been my morning. Like, I've hardly been out of bed before midday most days, just because it's miserable and cold and it makes you not want to do anything. It's a shit time of year. But you know, this is the southern hemisphere life. Thankfully, in Melbourne, we get sunlight until like 10 p.m. in summer, which is cool. Even later, I guess, at the peak of summer. So our long days are really long, but then our winters are really depressing. Okay, so this is wrong, right? We shouldn't have called this function again. For some reason, we've ended up here. We've ended up in the else, even though... I'm actually not convinced this isn't a problem with my... Like, I think my code gen might actually be okay here. This might just be a Breen issue. And then we push, and then we call it again. Okay. This isn't what I wanted, but something's happening. And then we're filtering out. We're filtering out. So, like, this is actually, for the number of iterations of this function that I did, for the number of times I called it recursively, this is actually the correct value of y that's being passed out as our return value, which is kind of weird. Like, I've got very mixed feelings about this because it gives us a consistent answer, an answer that I can understand looking at that assembly, but it's not the correct answer. It's just not the correct answer. One thing I really need to do, other than maybe hide this screen because I keep getting distracted by the fact that my stack overlaps with the region of memory I've mapped to this. One thing I really need to do is to annotate this program with offsets, so that I can see which, you know, when this says PC16, I don't have to go hunting through and find this line to work out what's going on. XMDI0, how many instructions is the ISA? It's about 16 or 17. It's pretty small. Let's have a look. Let's do a count. So it's one, well, it'll be this divided by 2 minus 1, so, oh, not quite. 1, 2, 3, 4, 5, 6, 7, 8. That, what happened? What did I do? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, but I've got a few more that I want to add. Like my load and store only work on on one word at a time, on 2 bytes at a time, which is a bit stupid. I need a load and store single byte. I need a variant. Also, I need to just change a few of the semantics around some of the instructions. Now that I'm doing code gen, it's just a little bit awkward, I can see. But yeah, the idea was a really small ISA that's very easy to compile into. But also, like, I have this generic stack instruction, which has this 4-bit stack op. So the stack instruction can actually do 16 different things. And in the virtual machine, it's like a little stack processor. It can push, it can pop, it can rotate the stack, it can add and subtract the top things of the stack. Like this, it's a very, yeah, like you could say that this is actually 16 different instructions, I guess, rather than just one. It's just how I've chosen to encode them, you know. But that's always the case with an ISA. It always does more things than if like, super minimal ISAs, it just encodes the different operations it can do in a different way. XMDI0, what were you working on? Are you doing programming live streaming as well? Okay, I'm going to step through this and I'm going to see why this comparison fails. So this is my goal. We push 7, which is good. We push C, which is good. We get our arguments into this function. And then we call it. And it's actually really funny because I noticed this was wrong because I saw that the arguments were in the wrong order in this stack frame visualization. XMPI0 does assembly program for x64, nothing this cool. Assembly programming for x64 is pretty cool. I respect that a lot. What kind of assembly programming? Like that's very broad. Like low level stuff. Are you trying to do like super optimized algorithms? What's the goal? Okay, we make room for locals. We load 1 as an immediate. Okay, so 1 our immediate here. And then we push this, then we load this, we push this, we pop it, we pop it. Okay, so what we do right now is we set up the stack. Now, there is another very important thing. Well, okay. The order of these is actually important, right? We're saying x less than or equal to 1. And I think what we're saying here is 1 less than or equal to x. But I need to double check how my... Well, actually, no, that's not true. That's not... The order on the stack doesn't matter, right? Because we... Where is it? I've lost it. Stack offset. Push... Test it. Yeah, I ended up somewhere else there. Hold on. Whoa. Where are we? This is so confusing. This is so easy to get lost with no line numbers. PC66, yeah. So we jump down somewhere. This is line 66. I know this. This is a fact. BC, test if B is less than or equal to C. So the thing on top of the stack is less than or equal to the second thing on the stack. So what do we push first? What do we push second? Sorry. Push that second. Excellent. So, okay, that's the correct order. B less than or equal to C. Okay. So we're going to see what happens. We push load offset. Okay, so we push 1 onto the stack. This is good. Now we pop into B, we pop into C. We test if B is less than or equal to C, which is true. Now we set up C, and we can see that C is non-zero. So because C is non-zero, we are gonna execute this instruction. We're gonna skip here and go straight to this, where we load A into our we load a value into the A register and then get ready to return. This is what should happen. Okay, so we jump to 104. Wait, I don't think that was right. But that should have been true. Ah, bugger. Okay, I'm gonna have to redo it. I'm gonna have to rerun it. I think something strange happened. You're implementing a bunch of scientific computing libs from scratch. Do I plan to do this in hardware or an FPGA? It would be really cool to do this as an FPGA. I think it's FPGA-able. I have no FPGA skills. That would be a whole other journey. But I would be very open to that. It would be cool to have a physical thing that ran my ISA, especially if I had my own programming language and stuff. My main goal is for this to just be a simple, lightweight computer that can run in a web browser so that people can experiment and just write code and run it in a no-friction environment, no operating system, no memory management, just write some data into memory. Currently this screen... I was playing around with this screen before. I had a couple of programs that drew stuff to this screen, and I'm not doing that now, but just the region of memory I'm using for the stack for this program happens to overlap with the screen, which is kind of fun. So there's just some garbage here. Okay, I need to step through all of this again because something strange happened. This is riveting, I'm sure, right? So we do this test, and we see this flag is true. So when we do this add if, the flag is the comparison flag is consumed, which is good. That's what we want to happen. And C is non-zero. So now when we do this test again, No, wait, we test if C... This is this thing where it's like I'm doing it's a double negative. It's a double negative. So both 0. So in this case, we don't skip an instruction and we do jump, but we should... Am I... Okay, I think I've worked out the test I need to write to make this work. I also love that every time I go to this scene, it's like I'm suddenly illuminated. I'm like in a blinding light. I've worked out the test that I need to write for this. Let's test mod. Okay, so if we're gonna write a good test, we're gonna write a really good test here. Is a... We're just gonna call a. Our function a... Actually no, yeah, this is gonna take an argument. And it's gonna take the argument 2. And we're gonna say if x is less than or equal to 1, return 7. Otherwise, we're gonna return 12. Okay? Because I don't actually think I have a test that verifies that we... Like, I know that we take a branch, but I don't know if I verified that we take the correct branch. So this is probably important to test, because I think this is what's going wrong here. I've had a bunch of issues calculating label offsets, and I think this is what's going wrong here at the end of the day. So we expect this to be 12. Now if I make t, if branch fails because we end up in the wrong branch. Excellent. Okay, this is good news. This is really good news, because this is very easy to fix. This is so easy to fix. Because right here, what we do, because what we test, okay? So we test if condition is falsy, pop both 0. Okay. So we compile this expression. This expression leaves a truthy value in the C register if it is true, which it is in this case, right? 1 is less than or equal to 1. So we expect there to be a truthy value in the C register. Okay, that's step 1. Step 2, when we come through here, we need to jump to the correct place. So if the condition is falsy, and this is indeed what we're checking if C is falsy, but it is not. So if they are both 0, if C is 0, then we skip over... If C is 0, if C... Oh my gosh, just the brain power. It's the double negative that's sneaking around here. If C is 0, then we want to execute the false branch. So why don't we just put the false branch... If C is 0... then we jump over... Okay, so this should be... Yes, this is what's wrong. So if C is non-zero, then we don't skip over this, which jumps to the true branch. Right? Right? So there's no label false now, but there is a unresolved instruction that loads Okay. This is what we do. And then out dot push unresolved instruction, we have a symbol, and this symbol is label true. Label out, label. And currently we can only have one if statement per program. They use a hard-coded label, but at some point we're going to do some kind of like gen sim and generate these accordingly. Okay, so what if I test now? Unload symbol. Sorry, this is a label. Excellent. Okay, that's better. That's better. We take the correct branch in our code. So now, if I recompile this program and I paste it in here and I run it, we should see 7 in the A register, and we do. This is good. This is good news. So what if I do put 3 in here? So we'd go 3, we'd go 2. Let's try it. I think it would either be 9 or 10, right? If I see 9 or 10 in A, I'm happy. Compile, run 9. Okay, this is good. We're honing in. We're really, really honing in now on what is going on here. So let's go back to our tests. Let's make sure that I'm actually doing this calculation correctly. Yeah, okay. So, I think this is fine. I think we're actually fine here. Let's go 5, and let's go 11. So we'd expect this. So we call A, and then we call A with 4 and 12, then 3 and 13, then 2 and 14, then 1 and 15, so we return 15. Beautiful. All our tests pass. So we've worked it out. The problem with recursion was that we were taking the wrong branch of the if statement. So we can come in, and I think we can check this off. I think recursion is fixed. I think we've done this a little bit. There's always more to do with testing. And then that leaves us with our bit of a refactor. And I definitely can make a bit of a start on this now, I think. I think that's a good idea. All right. So. This is feeling good. So good. Incredible. Thank you all for being on this journey with me while I do this extremely tedious refactoring. Oh yeah, let's do this as well. What's this? Stack sub wraps. Cool. Okay. This branch is getting big, but we're getting... Oh, actually, no, hold on. There's another thing we should do. There's another thing we should do before we start doing any refactors, getting into this. We should really think about making these symbols unique to the function, or unique to the block. So, okay. Let's write a function. Actually, let's see if I already wrote this somewhere. Where is this? Source. Okay, no, apparently not. Okay, so we need a function that's going to generate just a random identifier, and we're going to call it gensim because I like Lisp. So fn gensim. It's going to take a random number generator, I think, and that's going to be a box rand. I think it's going to be something like this, and it's going to give us back a string, I guess. It's going to give us back a string, and we're going to do something. Distribution. Yeah, here we go. So rand RNG, gen ASCII characters. We're literally just going to do this. We're going to go r.gen gen ASCII cars, take 16, and we're going to collect it into a string. Excellent. Use Cool. Thread RNG. So we get whatever random number generator is part of this thread. Then maybe put it in a box because we need to, because it's... Actually, do we? I don't think we need to do this, right? It just needs to impl this because it's an argument. I think that's okay. Can we build this? Rand. Do we not have rand? Oh, hold on. I read the question, not the answer. Rand. Is Rand not part of the Rust standard library? Is this something I actually have to explicitly depend on? It is. Oh my gosh. Like random numbers are pretty important. Okay. What was this called? What did they say I had to do? Sample iter alphanumeric. Sample iter rand alphanumeric. Take 16 map char from. That makes sense. Now we have to wait for this to download and build, so that's wonderful. Bobius. Yeah. It's weird, right? Sometimes you really just have a brain issue. Oh. This is actually what I meant. Alphanumeric. Not found in rand. Distributions. Let's do this, it's a little bit smarter. Build this. R is unused, remove the mutable. Okay, so now we're gonna let block identifier R doesn't need to be mutable, apparently. That's good. Okay, cool. Now when we generate this, we want to... What do we do? Block identifier. Can we add to a string? Oh, also actually we want this to be inside the if statement. Okay, so it's gonna be the block identifier, and then it's gonna be label true. Block identifier plus expected stir found string. This feels a bit silly, but that's okay. So basically now we can have multiple... R does not implement the copy trait. Moved here. Even better, maybe let's just go rand thread RNG. Block identifier has type string, which does not implement the copy trait. Can I add stir slices together? No. Interesting. Okay, so we've got a bit of Rust tomfoolery here. Well, I guess not really, because we can just string it, and then this will work. Cool. Okay, excellent. So now I could write another test. And I could nest some if statements inside each other. Let's see how that goes. Let's see if that will just work. Let's do my favorite copy and paste. It would be better to have a smarter testing harness that was able to do this. Okay, so if x let's say if x is greater than 1, let's if x, wait, I haven't implemented anything other than less than equal yet. If x is less than or equal to 7, return otherwise, return sure, let's just try this. Let's see what happens. Oh, except I can't call it the same thing. Let's say nested if um 5. Yeah, okay, that again feels okay. Let's maybe do another layer of nesting. Nice. And that looks like that works as well. So we've got unique labels for each if statement that appears in our program, each block. And this is really inefficient code, but we can start to do some cool stuff just with this. And it's nice how much of this just kind of works out the gate. Like I'm really enjoying that. I'm really enjoying that aspect of writing this. It goes to show that, you know, with 450 really disgusting lines of poorly thought out code, you can really go a long way. I'm actually getting the feeling this might be like a natural ebb that I can leave this at, and this is maybe a place where I can leave this branch. If I write some example programs that maybe, you know, that maybe do a bit of stuff, maybe that's a good place to leave things for a bit. And then I can do a refactor. Like, where am I going from here? I've got to do a big refactor to make my cargo workspace make more sense. Now that the compiler has kind of outgrown just being a binary inside source/bin, I think it needs to be its own kind of, you know, root in a workspace along with the VM. I think it makes sense for these two things to evolve together, kind of as independent projects, but inside the same repo. I need to do a lot of work to make this code gen smarter, but that's okay. We'll get there. That's cool. There are a few things I need, right? I need some kind of while loop. A for loop would be really nice. A for loop would be really, really nice, but not as important as a while loop. Then I need to start thinking about static memory. I need to start thinking about structs and how I'm going to handle structured data, because that's pretty important. And then that's probably the, well, oh, and I need to maybe have a concept of, I don't know if the language, I guess the language needs to have the concept of a pointer type as well, right? Like, am I storing a value in this local, or does this variable reference memory where I am storing a value? Once I can do that, it's gonna be a pretty functional language, and I'm gonna be able to do things like play around with this virtual screen and draw things other than random stack garbage to it, and that's gonna be a lot of fun. That's when things are gonna get crazy. Okay, but I'm gonna leave it there. We've had a little win. I've got a couple of things to do today, so I'm gonna go off into the world and hopefully work on this a bit more at some point today. Maybe streamed, maybe not. And then I've got to go hang out with friends and watch House of the Dragon later, which of course is very important. No spoilers. All right. So thank you everyone for stopping by. Shorter stream again today. But oh yeah, and no, I won't do the thing. But let's raid someone, because we got a couple of viewers. So if anyone has someone in mind that's fun to raid, anyone working on anything cool, I am always happy to hear about it. I'm always happy to throw them over. A couple of cool viewers. Chatting and game dev. Low-level streaming in Go. RTP Day 4. JPEG XS. That sounds kind of cool. That's my kind of thing. I love a good bit of low-level Go. This is, that really, I think that wins. Let's see what this person's doing. But yeah, thanks everyone who stopped by. Had a nice little raid. Thank you XMDI0 if you're still around. Um, yeah, this looks legit. This looks this looks pretty legit. So let's give this chap a raid. And as always, I'm doing a nice rambly outro, but thank you so much for tuning in, and I will hopefully catch you very, very soon.